Hi, everybody. The exam is up on campus. It's due next week on Thursday. Okay, it has 14 questions. Each question is worth 6 points. And today we're going to do review 2 together. Part 2, review 2, part 2. Okay, so the plan is to go through the rest of the topics and then do examples for both chapters until class is over. So the topics for chapter 17. Before I erase this, some things that have come up about the test are if you have trouble finding a math symbol, you can just spell it out. Like if you can't find the symbol for the mean, you can write the word mean, or you can just put the number down. If you have the correct answer and that's all you put, that's fine. Okay, chapter 17. Distribution. So the normal distribution is centered at the mean, which we call mu sub x. I feel like I'm missing a bit of notes. One moment. Let's see. Oh, yep, I skipped a little bit, but still. Okay, so I want to talk about x. The random variable x is normally distributed if it has a histogram that is bell-shaped. distributed histogram is bell-shaped. That part. Also, X is the measure of each outcome of an experiment. Okay. X is the measure of each outcome of an experiment. If the histogram for X is bell-shaped, then we call X a normal. We say that X is normal, or X has a normal distribution. Then we started talking about the graph. It's centered at the mean, and it has inflection points at mu minus sigma and mu plus sigma. So let's start with a picture. Okay, so this is a number line for all of the X values. And then we're drawing the distribution. It's a normal distribution, so it's bell-shaped. The other side is symmetric. So I'll do my best. Draw. We talked about the mean being right at the center where the peak is. Okay, and then we're also going to label inflection points, which is right there-ish, and about right there. So if you subtract one standard deviation, it matches up with the inflection point on this side. Mu sub X minus sigma. It's right there. And then add one standard deviation is where the other inflection point would be. Mu sub X, add sigma. All right, so those were the inflection points. First one, mu sub X minus sigma, and the other one is mu sub X plus sigma. So what will happen is you'll have a label for an inflection point, and you'll also know the mean, and use that value and the other one to find the standard deviation, the distance from an inflection point to the mean. And since it's symmetric, you could also do the other side, find the distance from the mean to the other inflection point. That's also the value for the standard deviation. Cool. So we've gotten bell-shaped. There. One more thing to note is this graph never crosses the x-axis. It gets really, really close, closer and closer, but never crosses over. Okay. We need to talk about the formula for the mean. So if you don't have a graph, but instead there's a table, you take the sum of all x times p of x. And that's the mean. And now I want to talk about area under the curve. The area under the normal curve is equal to, oh, we need a little bit extra. The area under the normal curve on an interval is equal to the probability of observing x on that same interval. So we'll use probabilities and match them with areas under the normal curve to solve our problems. And I have one more thing. Last part is so we're going to use the complement rule, but we're going to write it like this. When you have the probability of x being greater than a number, x is greater than some number a, it's equal to 1, and then subtract the probability of x being less than a. And it doesn't affect the overall area if you include a or don't include a. So you need to flip the sign, but if you have a strict inequality or you put an equal sign, it's fine. So you can have that there or not. Okay, so that's the end of all topics. Now we're going to do examples. So I want to do one more from chapter 16. And we're going to have a table sitting on the side with x, y, and the total. And other events are A, B, C. start here. Is 4 followed by 3. The total would be 7. Event B has 6 and then 5 with 11 total. Event C, 5, 3, 8 total. So this would be 15. Add along and get 8, 9, 10, 11. Make this 26. Then you can check adding the bottom row would be 18 plus 8, 26. All right. Let's find the probability of A. So the number of elements in A divided by the number of elements in S. And we're going to have 7 out of 26. Find the probability of Y. We have 11 out of 26. Next, the probability of A complement. I want to use 1 and subtract the probability of A. We're going to take 1, subtract 7 over 26. And that's going to be 26 over 26, minus 7 over 26. (19 out of 26). So if you are finding the probability of A complement and looking at the table, we can block out the total for A and then find the total for the other events, 11 plus 8. So that's our 19 divided by 26. Next, the probability for X. Your event X has a total number of elements being 15. And then get the probability by dividing by the number of elements in S. The probability of X complement, the complement of X. Take 1, subtract the probability of X. Minus 15 over 26. Out of 26. Take away 15 out of 26. Looks like 11 out of 26. Also, you can go to your table and you want the complement of x. So we don't want event x. Block it out. The other event is y, and that's 11 left over out of 26. I did get this good. Get this correct. Let's find the probability of x intersect b. So find x in the place where it overlaps with event b. Here and there. So that's 6. So the number of elements in x intersect b is 6. The probability would be 6 out of 26. Number 7. We want the probability of x union b. There's the formula for, it's called the general addition rule. Probability of x. Add probability of b. I'm going to actually start over. Let's see what underneath. Probability for x plus probability for b, and subtract probability of x intersect b. Okay, we had 15 over 26 for this part here. Probability for b. 11 out of 26. And then we got this part up here, 6 out of 26. 15 plus 11, and then subtract 6 out of 26. All right, let's see. This would be 26 minus 6 is equal to 20. Over here. 5. Let's reduce. They're both even numbers, so I'm going to factor out a 2. Looks messy. Okay, cool. 2 over 2 reduces to 1. I've got 10 over 13 left over. Let's do, let's try something like X union C. That's cool. the probability of X union C. And I think we're ready. So we're going to find the formula and take the probability of X, add the probability of C, subtract the probability X intersect C. So for X, we have 15 out of 26 as the probability. Probability for C. Find that total for C, 8 divided by 26. And then the probability of X intersect C. So let's go around the set X. C. Okay, so the place where they overlap is 5. And then we'll simplify. So out of 26 is 15 plus 8 minus 5. And it's that 15 minus 5 would be 10. 10 plus 8 is 18. Both even, so we're going to reduce. I can factor out a 2 from the numerator and 2 down here. 2 over 2 is going to be 1. This is 9 over 13. Okay, so we're going to move into chapter 17. All right, so I think we want to start with finding the mean for like a few different distributions. And then we'll start with then we'll go on to working with the normal curve the rest of the time. Call this, we're gonna do the same thing a few times, but number 1, we'll just relabel everything. Number 1, find the mean. So we have X values and then the probability for each of the values of X. Of X. With X being 1, 2, and 3. The first probability is 0.5 followed by 0.4 and 0.1. The mean for X is the sum of x times p of x. And you put in your x values. 1 times p of 1, add 2 times p of 2, add 3 times p of 3. Okay, 1 times 0.5 plus 2 times 0.4. And that last one, 3 times 0.1. Okay. Awesome. And we're going to simplify. The first one is 0.5. Next term is 0.8. And please catch mistakes if you see them. Let me know. Add 0.3. And we'll put this all together. I'm just going to grab the calculator. Ah, there we go. Cool. 0.5. Next one. Plus 0.3. I got 1.6. 0.8 plus 0.8. Yeah, that makes sense. Alrighty, let's try another one like this. Number 2. Find the mean. Oh, cool. All right. So we're going to have a new table. X values will be 0 to 4. Actually, we're going to do 0 to 4, 6. First probability is 0.3. The next one is 0.2. 0.4. 0.1. And the mean is the sum of x times p of x. And we're putting in 0, 2, 4, 6. All right, first x value. 2 times p of 2. I'm going to add 4 times p of 4. And add 6 times probability of 6. Okay, I I'm going to put in all the probabilities. 3 is the first one. Plus 2 times 0.2. 4 times its probability, 0.4. And 6 times 0.1. Okay. I'm going to fix this. I should have just erased. Okay, so here to here to here, it's a 0 plus 0.4 plus 1.6 and 0.6. Okay, so here we've got 2, and then add 0.6. Okay, so last one of these, and we'll change it up. So the table is going to have x and p of x. We're going to put 0, 5, 10 for x. Probabilities are 0.7, 0.1, 0.2. Okay. Mean is sum of x times p of x. This time your x values are 0. Then add, putting in 5. And then put in 10. Okay, we're fine. We're going to 11:45. Okay. Yeah, 0 times 0.7. Here. Plus 5 times 0.1. And add 10 times 0.2. First part's going to be 0. 0 times the number is 0. 5 times 0.1, 0, 1, 5. Add 2 times 10. It's going to be, oh, that's not good. Okay, So point, oh, it's like 2. Move that point over. And this is 2.5 total. So let's go on to having a graph for a normal distribution, and you need to find the mean and standard deviation. All right, the center is 57. And we're going to have the inflection point be 47 on this side and 67 on the other. Okay. The mean would be 57. The standard deviation is the distance between the mean and that inflection point, which is 10. Or from here to here, from 47 to 57 is a distance of 10. That's your standard deviation. This time, your mean is 34. The inflection points are at 32 and 36. Find the standard deviation. Let's see now. So you can use this side of the graph or this side of the graph, but it's the distance between 32 and 34, or from 34 to 36. So from here to here. And again, if all you put is 2, that's fine. You don't have to find this symbol, and also I don't require that you show your work, but if you do show your work, it kind of helps me understand what your thought process was. It helps me give comments or like feedback on my grade. All right, let's go over to something new. So the last few examples are using areas underneath the normal curve to find probability for like the random variable. Let x be normally distributed with a mean of 24. All right. Standard deviation is equal to 13. In this case, we have the area under the normal curve to the left of 26. It is 0.56. And then you're asked to find the probability that x is less than 26. So what we're going to do is draw a picture and then match the area under the curve with the probability we're looking for. Okay, the normal distribution means it has a bell-shaped, and the mean is the center, so it's centered at 24. And you have an area under the curve on the left of 26. 26 is up here. And you're going from there to the left, this way. From that number, go straight up to the curve. And then shade in all of the area. It can be dots or solid. It doesn't change the area really. Just stay the same either way. Okay, and that is 0.56. The probability that x is less than 26. So first find the interval where x is less than 26. Going from that number over this way. And the probability on that interval is the area under the curve for the same interval. So we're just matching up the probability with the area that we were given. Next example. X is normally distributed. with mean of 50 and standard deviation 7. Then the probability that x is greater than 65 is equal to 0.0162. Find the probability that x is less than 65. And for these problems, I included a picture. We're going to draw the picture, the graph. It's bell-shaped and centered at 50. And then the part we have is for the x values that are greater than 65. So find 50, 55, 60, 65. The interval we want goes from, that we know about, goes above 65. X value is greater than 65. So on that interval, the probability is equal to the area under the curve. And that area is going to be 0.0162. Okay, but we want the other side. We want the probability that x is less than 65. So we want those x values that are below 65. And the probability on that interval is this area that we didn't shade. Which the full area is 1, and then you subtract the shaded area, and it leaves the one that we're interested in. So take 1, subtract 0.0162. Back to this. The probability that x is less than 65 is equal to 1 subtract probability of x being greater than 65. One minus 0.0162. And that is 0.9838. Okay. Last example. We are going to say that the time it takes to study for an exam is normally distributed. Let's do this. The study times. Normally distributed. With the mean of 4 hours and standard deviation of 2 hours. We're going to let the random variable x be equal to the time it takes to study for an exam. Or study time for the exam. Then the probability that the time it takes to study for the test is more than 5 hours equals 0.3085. But we're going to use math symbols to save some time. Then the probability that the time it takes to study for the exam, which is x, is more than 5 hours, greater than 5, equals 0.3085. And we're going to find the probability that x is less than 5. Okay, so it's going to say find something like probability that it takes less than, that the number x is less than 5 hours. Let's see, I think, oh yeah, we've got 10 minutes. So we're going to draw a picture and then we'll work out the problem. And that's it. It's normal distribution, so bell shape. The mean was 4 hours. want to find the probability of studying for less than 5 hours. So we'll find 5. Oops. Here's 4, there's 5. We want to go less than 5 this way. And find the corresponding area. So this is what we want. Part we have is for probability of x greater than 5. Okay, so here, the interval where x is greater than 5. Like this. Greater than or equal to. Either way, doesn't matter. And that's the interval. The probability is the area under the curve, this part. And you're told that that area is 0.3085. And the full area is 100% total. So we want to do 1 subtract 0.3085. Okay, so we're taking our problem. We're looking for the probability that x is less than 5. Use the complement rule. It's 1 subtract probability that x is greater than 5, which is 1 minus 0.308. Okay, we get 0.6915. So that was that unshaded side. That's the end of the review. So those are the kinds of problems on the test. If you have any questions, we can talk about them Tuesday, or you can write an email to me.